Article 350.12 of the National Electrical Code, or NEC, addresses the secure fastening of flexible metal conduit, also known as FMC. This section mandates that FMC be securely fastened in place using straps, ties, or other approved methods. The key requirement is that this fastening must occur within 12 inches of every box, conduit body, or other termination point. The point of contention often arises in interpreting what constitutes a termination. In a specific scenario of transitioning from electrical metallic tubing known as EMT to FMC, the connection point is indeed considered a termination. Consequently, adherence to NEC Article 350.12 necessitates strapping the FMC within 12 inches of the EMT conduit body. This requirement ensures the mechanical integrity and stability of the conduit system, preventing stress on the connections and maintaining proper grounding. The NEC focus on securement aims to minimize the risk of damage to the conduit and the conductors it houses, which could lead to electrical hazards. Therefore, understanding and correctly applying the termination rule is crucial for compliant and safe electrical installations. Firstly, the importance of understanding the definitions within the NEC. The NEC provides definitions for various terms, and these definitions are legally binding for installations within the jurisdiction adopting the NEC. While termination is not explicitly defined in the NEC in a way that directly addresses the FMC to EMT connection, the intent of the code is clear when considering the broader context of conduit support. Secondly, consider the purpose of the 12-inch rule. This rule is designed to prevent excessive movement and strain on the conduit and its connections. Unsecured conduit can vibrate, sag, or be subjected to physical stress, potentially leading to loose connections, damaged conductors, or even conduit failure. By requiring support within 12 inches of a termination, the NEC minimizes these risks. Thirdly, examine typical installation practices. In practical applications, electrical inspectors commonly interpret the FMC to EMT connection as a termination requiring support. This interpretation is based on the understanding that the connection point is where the flexible conduit ends its run and transitions to a different wiring method. Fourthly, understand the role of conduit bodies. Conduit bodies, such as LB, LL, LR, and T fittings, are explicitly mentioned in Article 350.12 as points requiring support within 12 inches. The FMC to EMT connection serves a similar function to a conduit body as it facilitates a change in direction or wiring method. Therefore, it logically follows that it should be treated as a termination requiring support. Fifthly, review relevant documentation and manufacturer's instructions. Many manufacturers of FMC connectors provide instructions that recommend or require support within a certain distance of the connector. Consulting these instructions can provide further clarification on the proper installation practices. Sixthly, consider potential issues arising from non-compliance. Failure to properly support FMC at the EMT transition can lead to several problems. These include strain on the connectors, loosening of connections, damage to the conduit or conductors, and potential safety hazards. Seventhly, discuss with local inspectors. Ultimately, the interpretation of the NEC is up to the authority having jurisdiction, or OJ, which is typically the local electrical inspector. If there is any doubt about the proper application of the code, it is always best to consult with the local inspector for clarification. Eighthly, remember best practices. Even if the local inspector does not explicitly require support at the FMC to EMT transition, it is often a good practice to provide support anyway. This can help to ensure the long-term reliability and safety of the installation. Ninthly, consider the specific application. In some cases, the specific application may influence the need for support. For example, if the FMC run is short and relatively straight, and the connection to the EMT is secure, the need for additional support may be less critical. However, in other cases, such as when the FMC run is long or subject to vibration, support is essential. Tenthly, stay updated with code revisions. The NEC is revised every 3 years, so it is important to stay updated with the latest changes. Future editions of the NEC may provide more specific guidance on the support of FMC at EMT transitions. Now consider the practical implications of this requirement. Firstly, selecting the appropriate strapping method. A variety of straps and ties are available for securing FMC. The choice of method depends on the size of the conduit, the mounting surface, and the environmental conditions. Common options include metal straps, plastic ties, and cable clamps. Secondly, ensure proper strap spacing. While the NEC requires support within 12 inches of a termination, it also specifies maximum intervals for support along the entire length of the conduit run. These intervals vary depending on the size of the conduit and the application. Thirdly, consider the mounting surface. The method of attachment to the mounting surface must be appropriate for the material of the surface. For example, when attaching to concrete anchors should be used. When attaching to metal, self-tapping screws or bolts can be used. Fourthly, protect against corrosion. In corrosive environments such as those found in industrial facilities or coastal areas, it is important to use corrosion-resistant straps and connectors. Galvanized steel or stainless steel are common choices. Fifthly, maintain proper grounding. The conduit system must be properly grounded to provide a path for fault current. This is typically accomplished by using grounding bushings and bonding jumpers. Sixthly, avoid over-tightening straps. Over-tightening straps can damage the conduit or the conductors inside. The strap should be tightened only enough to securely hold the conduit in place. Seventhly, inspect the installation. After the installation is complete, it is important to inspect it to ensure that all straps are properly installed and that the conduit is securely supported. Eighthly, address any deficiencies. If any deficiencies are found, they should be corrected immediately. This may involve retightening straps, adding additional supports, or replacing damaged components. Ninthly, document the installation. It is good practice to document the installation, including the location of supports, the type of straps used, and any other relevant information. This can be helpful for future maintenance and troubleshooting. Tenthly, maintain ongoing maintenance. The conduit system should be periodically inspected to ensure that the supports are still in good condition and that there are no signs of damage or corrosion. In conclusion, understanding and applying the NEC requirements for supporting FMC at EMT transitions is essential for ensuring the safety and reliability of electrical installations. By following the guidelines outlined in Article 350.12, and consulting with local inspectors, electricians can ensure that their installations are compliant and safe. Let's delve deeper into the specifics of NEC Article 350.12 and its implications for FMC installations. The core of the requirement lies in the phrase securely fastened in place. This phrase emphasizes the importance of using appropriate methods and materials to ensure that the FMC is adequately supported. The NEC does not explicitly define what constitutes securely fastened, but it implies that the support must be capable of withstanding the expected mechanical stresses without allowing the conduit to move or sag excessively. This is crucial for preventing strain on the connectors and ensuring the long-term reliability of the electrical system. Furthermore, the phrase by straps, ties, or other approved means provides flexibility in the selection of support methods. Straps are typically metal or plastic bands that encircle the conduit and are attached to a mounting surface. Ties are typically plastic or nylon zip ties that can be used to bundle the conduit to other objects or to support it from above. Other approved means could include specialized clamps, hangers, or other devices that are specifically designed for supporting conduit. The key is that the chosen method must be approved by the authority having jurisdiction and must be suitable for the specific application. The 12-inch requirement is a critical aspect of Article 350.12. This distance is measured from the edge of the box, conduit body, or other termination point to the nearest support. The purpose of this requirement is to minimize the unsupported length of the conduit, which can help to prevent sagging and strain on the connections. In the case of an FMC to EMT transition, the termination point is considered to be the point where the FMC connects to the EMT conduit body. Therefore, The first support must be located within 12 inches of this connection point. Now let's consider some practical examples of how to apply Article 350.12 in different scenarios. Firstly, imagine a situation where FMC is being used to connect a motor to a junction box. In this case, the FMC must be supported within 12 inches of both the junction box and the motor connection. This ensures that the FMC is securely supported along its entire length and that there is no excessive strain on the connections. Secondly, consider a scenario where FMC is being used to run wiring above a suspended ceiling. In this case, the FMC can be supported by attaching it to the ceiling grid using cable ties or other approved methods. The supports must be spaced at intervals that do not exceed the maximum allowable spacing specified in the NEC. Thirdly, imagine a situation where FMC is being used to run wiring in a wet location. In this case, it is important to use corrosion-resistant straps and connectors. It may also be necessary to provide additional support to prevent the conduit from sagging due to the weight of the water. The NEC provides additional guidance on the support of conduit in specific situations. For example, Article 348.30 of the NEC provides requirements for the support of intermediate metal conduit, or IMC, and Article 352.30 provides requirements for the support of rigid polyvinyl chloride conduit, or PVC. While these articles do not directly apply to FMC, they can provide useful insights into the general principles of conduit support. It is also important to consider the manufacturer's instructions when installing FMC. Many manufacturers provide specific recommendations for the support of their products. These recommendations may be more stringent than the NEC requirements, and they should always be followed. In addition to the technical requirements, it is also important to consider the aesthetic aspects of conduit support. In many cases, the conduit will be visible, and it is important to ensure that the supports are neat and professional looking. This can be achieved by using consistent spacing, aligning the supports properly, and using appropriate hardware. Now let's address some common misconceptions about FMC support. One common misconception is that FMC does not need to be supported if it is run in a concealed location. This is not true. The NEC requires that all conduit, including FMC, be supported regardless of whether it is concealed or exposed. Another common misconception is that cable ties are not an acceptable method of supporting FMC. This is also not true. Cable ties can be used to support FMC, provided that they are approved for the purpose and that they are installed in accordance with the manufacturer's instructions. A third common misconception is that the 12-inch rule only applies to the first support after a termination. This is not true. The 12-inch rule applies to all supports within 12 inches of a box, conduit body, or other termination point. To summarize, Article 350.12 of the NEC requires that FMC be securely fastened in place by straps, ties, or other approved means within 12 inches of every box, conduit body, or other termination point. This requirement applies to all FMC installations, regardless of whether the conduit is concealed or exposed. By following these guidelines, electricians can ensure that their installations are compliant, safe, and reliable. Furthermore, consider the importance of proper planning before starting the installation. Before beginning any FMC installation, it is essential to carefully plan the routing of the conduit and to identify the locations of all supports. This will help to ensure that the installation is neat, efficient, and compliant with the NEC. Planning should include selecting the appropriate type and size of conduit, determining the best method of support, and identifying any potential obstacles or challenges. It is also important to consider the environmental conditions in which the conduit will be installed. In wet or corrosive environments, it is necessary to use corrosion-resistant materials and to take extra precautions to protect the conduit from damage. Another key aspect of proper planning is to ensure that all necessary tools and materials are available before starting the installation. This will help to avoid delays and to ensure that the work can be completed efficiently. Tools that may be needed include a conduit bender, a conduit cutter, a drill, a screwdriver, and various types of straps, ties, and connectors. Materials that may be needed include FMC, EMT conduit bodies, straps, ties, connectors, grounding bushings, and bonding jumpers. Once the planning is complete, the actual installation can begin. The first step is to cut the conduit to the desired length. This can be done using a conduit cutter or a hacksaw. It is important to cut the conduit squarely and to remove any bows or sharp edges. The next step is to install the connectors on the ends of the conduit. The type of connector used will depend on the type of fitting to which the conduit will be connected. Common types of connectors include compression connectors, set screw connectors, and threadless connectors. After the connectors are installed, the conduit can be routed to its final location. It is important to avoid sharp bends or kinks in the conduit, as these can restrict the flow of current and can damage the conductors inside. Once the conduit is in place, the supports can be installed. The supports should be spaced at intervals that do not exceed the maximum allowable spacing specified in the NEC. The support should also be installed in a manner that provides adequate support and prevents the conduit from sagging or moving excessively. After the supports are installed, the conductors can be pulled through the conduit. It is important to use the proper pulling techniques to avoid damaging the conductors. Once the conductors are pulled through, they can be terminated at the appropriate devices. The final step is to inspect the installation to ensure that it is compliant with the NEC and that it is properly grounded. Any deficiencies should be corrected immediately. Now, let's delve further into grounding and bonding considerations when using FMC. Proper grounding and bonding are essential for ensuring the safety of electrical systems. Grounding provides a path for fault current to return to the source, while bonding ensures that all metallic parts of the electrical system are at the same electrical potential. FMC can be used as a grounding conductor under certain conditions. Specifically, the NEC allows FMC to be used as a grounding conductor if it is installed with listed fittings and if it meets certain other requirements. However, it is generally recommended to install a separate grounding conductor inside the FMC, especially in critical applications or in environments where corrosion is a concern. The grounding conductor should be sized in accordance with the NEC and should be connected to all metallic parts of the electrical system, including the boxes, conduit bodies, and equipment enclosures. Bonding jumpers are used to connect different sections of conduit together and to connect the conduit to other metallic parts of the electrical system. Bonding jumpers should be sized in accordance with the NEC and should be installed in a manner that provides a low impedance path for fault current. In addition to grounding and bonding, it is also important to consider the ampacity of the conductors that are installed in the FMC. The ampacity of a conductor is the maximum amount of current that it can safely carry. The ampacity of a conductor is affected by several factors, including the size of the conductor, the type of insulation, and the ambient temperature. The NEC provides tables that list the ampacity of conductors under different conditions. It is important to consult these tables to ensure that the conductors are properly sized for the intended application. Another important consideration is the fill capacity of the conduit. The fill capacity of a conduit is the maximum amount of conductor that can be installed in the conduit. The NEC provides tables that list the fill capacity of conduits under different conditions. It is important to consult these tables to ensure that the conduit is not overfilled. Overfilling a conduit can cause the conductors to overheat, which can lead to insulation damage and even fire. Let's now consider some best practices for installing FMC in various environments. Firstly, in damp or wet locations, use liquid-tight flexible metal conduit, or LFMC, instead of standard FMC. LFMC has a waterproof jacket that protects the conductors from moisture. Secondly, in corrosive environments, use corrosion-resistant materials for all components of the conduit system, including the conduit, connectors, and supports. Thirdly, in areas where there is a risk of physical damage, protect the conduit with a guard or shield. Fourthly, in areas where there is a risk of explosion, use explosion-proof conduit and fittings. Fifthly, when running FMC through fire-rated walls or floors, use fire-stopping materials to maintain the integrity of the fire rating. Sixthly, when running FMC in a hazardous location, comply with the requirements of Article 500 of the NEC. Seventhly, when running FMC in a healthcare facility, comply with the requirements of Article 517 of the NEC. Eighthly, when running FMC in a commercial building, comply with the requirements of Article 725 of the NEC. Ninthly, always follow the manufacturer's instructions for installing and supporting FMC. Tenthly, always consult with a qualified electrician if you have any questions or concerns about installing FMC. Now let's address some common troubleshooting issues with FMC installations. Firstly, if the FMC is sagging, add additional supports. Secondly, if the connectors are loose, tighten them or replace them. Thirdly, if the conductors are damaged, replace them. Fourthly, if the conduit is corroded, replace it. Fifthly, if there is a ground fault, troubleshoot the circuit to find the cause of the fault and correct it. Sixthly, if there is an overload, reduce the load in the circuit or increase the size of the conductors. Seventhly, if there is a short circuit, troubleshoot the circuit to find the cause of the short circuit and correct it. Eighthly, if the circuit breaker is tripping, troubleshoot the circuit to find the cause of the tripping and correct it. Ninthly, if the lights are flickering, troubleshoot the circuit to find the cause of the flickering and correct it. Tenthly, if the equipment is not working properly, troubleshoot the equipment to find the cause of the problem and correct it. In conclusion, installing and maintaining FMC requires careful planning, proper techniques, and a thorough understanding of the NEC. By following the guidelines and best practices outlined in this narration, electricians can ensure that their FMC installations are safe, reliable, and compliant with the code.